Okay, here we are in the last section of the chapter, 3.9. And you've actually had a couple of these problems throughout this chapter. I have not taught it, but the authors thought you were capable of doing it. And what you were doing when you were going backwards, when they would give you a derivative and you were going backwards, that's called antiderivative. So this last section is all about how to find an antiderivative. So an antiderivative is the function that has without an e, that has the given function. It actually has the given derivative. Okay, so we're just going to jump right into examples. So the first one will start easy. If I tell you the derivative, y prime, equals x to the 7th, can you come up with the antiderivative? The antiderivative is the equation that ends up with this derivative. Okay, we always start with that exponent. We know the power rule. We know that we subtracted 1 when we did a derivative. So you start by saying y equals, you know it had to be x to the 8th. Leave a little space here because we're probably going to have to put a number out there. So off to the side, I like to say, well, if I start with x to the 8th, just what I know it is, and I do the derivative of this, I'll see what I end up with. So if I do this derivative, that's going to be 8 x to the 7th. Well, if I look back, I just want x to the 7th. I don't want the 8 there. So what's the number that has to go in front that's going to cancel out this 8 that I get when I multiply down? Well, think about 8 times what number gives me 1. 8 times what number? I want to equal a 1 because there's a 1 out in front here. Well, it's going to be 1/8. So I should have a 1/8 out in front of my x to the 8th. Or I could call it x to the 8th all over 8. Either one. 1/8 x to the 8th or x to the 8th over 8. So now when I multiply down, if I put a 1/8 out here, when I multiply down, 1/8 times the 8 that I multiply down gives me the 1, x to the 7th, and that's what I wanted. Okay, now my question is this the only equation that has x to the 7th as its derivative? And at first guess, you might say, well, yeah, but take a look. If I had x to the 8th over 8 plus 10, would that equation have the same derivative? Well, you know, this is going to come out x to the 7th. What's the derivative of 10? 0. So there's another equation that has that same derivative. What about x to the 8th over 8 minus 2.35? Oh, yeah, that goes to 0 too. How many equations have that derivative? We could be here all day. So what we do to accommodate the fact that there could be a constant here, we don't know what it is, when we do antiderivative, we say it's y equals the part we came up with, x to the 8th over 8 plus some constant value of c that I don't know. It might be a 0. It could be any other number. So there is the true general equation for the antiderivative. General equation for the antiderivative. In a few examples, we're going to be doing a particular equation, finding out what the c is, but we don't have enough information at this point to figure out what c is. And you'll see in a little bit how we can figure that out. So let's try another one, just finding antiderivative. So if the derivative equals negative 9.8 t, can you find what equation has that derivative? Again, I like to leave a space in the front. Start with the exponent. That's the only thing you know for sure, is that the t had to be to the 2nd power, because that's t to the 1st right now. Add 1 to it. So now off to the side, over to the side, I'd like to do the derivative of this. If y equals t squared, my derivative would be 2t to the first. Well, I don't want 2t to the first. I want negative 9.8t to the first. So then I got to ask myself, well, 2 times what number that I put here is going to give me this answer of negative 9.8. So it's just a simple divide by 2. And would have to equal a negative 4.9. Now I know it has to go here. So if I check, 2 times negative 4.9, it's going to give me the negative 9.8 t to the first. And don't forget all of those other equations that I could have if I had a plus some constant value here that goes to 0, has that derivative. So don't forget the plus c's when you're doing antiderivative. Let's try a trig one. Let's start easy. F prime of x equals sine x. As easy as it gets. So you ask yourself, what function has sine as its derivative? Well, if you need to look on your blue sheet, well, you know cosine's derivative is negative sine. So let me just start with cosine. I may still have to put a number in front here. So off to the side, check the derivative. Let's see. So the derivative of cosine is a negative sine x. The derivative of the angle here is just 1, so I don't even need it. So I've got negative sine x, but I want a positive sine x. So what would have to be out in front here to cancel out this negative when I multiply? Or actually do the derivative, I need another negative. So negative cosine of x. And don't forget the plus c. There's your general antiderivative equation. Or let's go with the derivative of g is the cosine of 7x. We're going to find out what g started out as. So the antiderivative equation, so you got to ask yourself, what function has cosine as its derivative? Well, you know it had to start out as a sine. Leave a space in the front. So at that's as far as you go, and then the rest of it's kind of a guess and check kind of, not really guess and check, but you check the derivative. So I'm starting with sine of 7x. I'm going to do derivative. So the derivative of a trig function is the trig function, and then the derivative of the angle. So sine's derivative is cosine. Keep the angle the same, but then I have to remember I'm going to be multiplying by the derivative of the angle is a 7. So if I was to leave this as my derivative, my antiderivative would be 7 cosine 7x. Well, I don't want a 7 cosine 7x. I want a 1 to end up there. So I need to have a multiplier out in front that will cancel out this 7 and bring it to a 1. Well, that's easy enough. That's 1/7. And then a plus c. So if I had my 1/7 here, that 1/7 would carry along. 1/7 times the 7 goes away, and I get the 1 that I want. Alright, a little trickier. Let's go y prime equals the quantity 3x plus 6 to the 6th. So I see the derivative has an inside and an outside, so I know power rule happened. So start with the exponent. I know that this inside, leave a space, started out to the 7th power. I know it had to be 1 more than that, so if I check right now, 3x plus 6 to the 7th. If I check the derivative of this, my 7 would come down. My inside stays the same. And then I have to multiply by the derivative of the inside yet. Derivative of the inside is a 3. And that goes to 0. So my derivative would be 21. 3x plus 6 to the 6th. Well, I don't want a 21. If I look, my derivative has a 1 out here. So I've got to cancel out a 21. And, well, not cancel out, but bring it down to 1 when I multiply. So I need a 1 over 21. So if I had that 1 over 21 here, when I multiply down by the 7, that would give me the 1 out in front. Oh, did that work? Yeah. Yeah. And then don't forget, plus c. Okay, next one. If the derivative is x squared minus 8x plus 2, what was the original function? Well, this one, there's no inside, there's no parentheses, there's no trig functions, it's just each term. So we do each term separately. So pretend these aren't here. This term, you know, reverse the power rule. You know it started out 1 higher than that, so leave a space, but it's got to have an x cubed in it. Okay? And if I just work on this, the derivative here, if I do it underneath, would be 3x squared. Well, I don't want 3x squared, I want a 1. So what has to be in front here? Is a 1/3. Now we move on to the middle term. Okay, the exponent on the x is a 1, so you know it had to start out with an x squared. If I check the derivative of x squared is 2x to the first. Well, I want 8x to the first, so what had to be out in front here was a 4. That gives me my 8x. Okay, I've got a constant left of 2. That means, if you think about it, this was x to the 0, because anything to the 0 power is 1. So when I reverse my power rule, I had x to the first. The derivative of 2x goes to 2. And there it is. And don't forget, there could have been a constant on the end, whose derivative goes to 0, and that would give that derivative up there. So these are my derivatives under here. They're not a part of the answer. That's just how I check to see what the front number has to be. Alright, now we're going to switch gears a little bit. We want to find the particular equation. Antiderivative equation. Which means they have to give you more information. So this is what they're going to give you. If the derivative equation is 2x plus 2, and we know that the point 1, 5 is on f of x. It's on the original function, a point. That's going to let me figure out the c value. So, the first part we got to do is find the general equation. So we reverse the power rule. So again, think of this as x to the first. So you know it had to be an x squared. If I check the derivative here, it would be 2 comes down, it would be 2x. And that's exactly what I had there, so I don't want a number in front. 1 is fine. Then what has a derivative of 2? That would be 2x. If that's x to the first, that comes down, gives you the 2, that goes away. And then I'd have my plus some c value. Okay, that's my general